Well, welcome to Chapter 5. Here in Chapter 5, we're going to be working on something that's really, really important, and that is identities. And so, what's going to be ultimately happening is we're going to give you a trig expression, and we want you to go through mathematical arguments to show that it's something else. And so the design of 5.1 is to present the fundamental identities. Again, you can bring notes to the exam, so you could bring these fundamental identities with you. The tricky part is to apply them in such a way to get what you need to accomplish. They're going to at times ask you to go through some pretty prescribed methods so that you get used to using a method like that. But what we want out of this is a learning process in which you apply something and you say, oh, this is the situation in which I probably should try this. And I can tell you that there's no one path in order to do this. Usually there's multiple paths. And therefore, you should just come in saying, there's got to be a way to make this look like this, and then be creative. So this is not your traditional math where there's a very prescribed formula to go through and we're going to get it. This is more of sophisticated math and actually an underlying idea that's going to be needed in other places. So I just wanted to set the framework for that. Some of these identities you already know. You already know that cotangent is 1 over tangent. So I'm just going to focus on these fundamental identities here, make it bigger. We already knew that cotangent was 1 over tangent, secant 1 over cosine, cosecant 1 over sine. Sometimes those will help you in the sense of getting everything in terms of one trig function. Tangent could also be rewritten as sine over cosine, and equivalently cotangent can be written as cosine over sine. And then we have these Pythagorean identities. They shouldn't be shocking to you because you know about the angles. We already, especially the first one, probably easy to prove. The other ones are consequences of it. But if we, let me not underline it, let me highlight it a little bit. So if I come in here, maybe, there we go, and grab a highlighter and just highlight this one right here. That fundamental identity really comes from the fact that you know what an angle looks like. That if we had an angle theta here, that its sine would correspond, well, if it was, especially if it's on the unit circle, let's suppose it's on a circle of radius 1, then you know that this is x and y, if those are the points. Well, you know then that x squared plus y squared equals 1 because you have a right triangle. That's where that one's coming from. The other ones are natural consequences of that. So let me get in here and just erase for a moment. Let's focus on this next one. I actually personally only have this one memorized, the sine squared plus cosine squared equals 1. If I need the other one, I figure it out. So what I mean by that is, if I'm in a situation that has a secant squared or a tangent squared, and I think, oh, I'm going to need that Pythagorean identity, if I don't have the ability like you will on the test to bring this with me, what I can easily do is say, oh, I know that sine squared theta plus cosine squared theta is equal to 1. And this perspective will help you see how things get manipulated with trig functions and why trig is a tool for later mathematics. Trig is not just something to know, we're actually having you use it, and it's the basis, one of the prerequisites for calculus because you need it. So let me come in here, and in red pen I'm going to say, let's suppose it was tangent squared that was in my thing, and I'm like, I know I'm going to have to replace that tangent squared. I know that tangent squared sine, well, I know tangent sine divided by cosine. So tangent squared is sine divided by cosine squared. So if I just go force that tangent by doing the same thing to every term, which we know from our pre-algebra days, reinforcing algebra yields the same question, or same equation, same solutions. Sine squared divided by cosine squared, what's that? That's tangent squared. Cosine divided by cosine, that's 1. 1 divided by cosine, well, that's secant. Oh, secant squared. 1 divided by cosine squared. That's secant squared theta. That's where they're getting this guy right here. So not by coincidence the same. Equivalently, if I were to divide everything by sine, I would have this guy, or sine squared, I should say. So really, you can memorize just one. Why am I talking about memorization? Because I know you're able to use notes here, but as you go into calculus, if you open up any calculus textbook, just to the front cover, guess what's going to be there, either on the front cover or the back cover? All the trig identities. Some statements about some core trig that you already know, like the sine of pi over 6 is 1/2, cosine of pi over 6 root 3 over 2. They're going to have that information on there because you're going to use it, not because they're going to have a trig section, but they're going to have trig problems, and you'll do things like trig substitution. You'll introduce trig when it's not even there. So there's some negative angle identities. These come from the fact that sine and cosine are sines an odd function, cosine's an even function, and so we get sine of negative theta is equal to negative sine theta. They were wise to put the cosecant right below it. Whoever did this set up this thing, because they're interrelated. They're going to have the same relationship. Cosine of negative theta is the same as cosine theta, right? And tangent of negative theta is the same as negative tangent theta, and then same with the cotangent as well. You'll use those from time to time to get rid of negatives, things like that. So we want you to just be well versed in all of this. And how do you get well versed in this? You do problems. Okay? And so they had this exercise 1 way back in an earlier part of either chapter 1 or chapter 2, probably chapter 2. And we needed to identify all the different trig functions. We were given one, we were told what quadrant, and we drew pictures. The intent of this question right here is to get you to use the identities. So when you're doing a problem here, they want you to use the identities. We will have to put on our chapter 2 hats. I am going to draw a picture just for a moment. I'll keep the blue, but maybe I'll switch to a different color. We know that they want us to find sine theta and only sine theta. If secant theta is equal to 7/2, we'll go, oh, that's easy. All we have to do is flip it. But remember, secant's the flip of cosine, not the flip of sine, so it's not that easy. But what do we know? We know our secant's positive, which implies that our cosine is theta. Well, we know what cosine theta is. It's 2/7. Let me just write that. So cosine theta is positive, and tangent's negative. Well, where is cosine positive? Cosine's positive in quadrant 1 and 4. Out of those two quadrants, where is tangent negative? Oh, it's got to be a quadrant 4 angle. Okay, so I remember that the only thing positive in here, in quadrant 4 where I'm at, is cosine and its flip. Remember that. So we absolutely know, let me switch to black, that cosine of theta is 2/7. We want sine theta, no problem. We know that sine squared theta plus cosine squared theta is equal to 1. So that means sine squared theta plus 2/7 squared is equal to 1. That means sine squared theta plus 4/49 is equal to 1. That means sine squared theta is equal to 1 minus 4/49. Now, it's straightforward arithmetic here. I was going to say simple arithmetic. I'll back off from that. 49/49 minus 4/49. Oh, no problem. Sine squared theta is equal to 45/49. Now, we don't want sine squared theta. We want what sine theta is. So what sine theta is, it's the square root of 45/49, and you have to pick the sign. So the whole reason they told us what quadrant we are in is that you remember from your algebra days that when you put on this, whoops, let me not do it like that. When you put on the square root, you have to do a plus or minus. Whoops, not there, usually with the number, plus or minus with the number. Now, that means there's two answers, but there's only one answer for us because we're in quadrant 4. In quadrant 4, is the sign positive or negative? It's negative. If it was a quadrant 1 angle, where cosine would also be positive 2/7, then we would have positive. But we knew from the beginning that it was quadrant 4 from our chapter 2 work. And so it's a negative in there. And now all we have to do is our algebra 1 work of splitting up that square root. So we have a 7 on the bottom. 9 times 5 is 45, so this is 3 root 5. So it's a negative 3 root 5. Leaving off the negative means you didn't take into account didn't take into account that that it was a quadrant 4 angle, right? That whole second piece in there. Same thing going on here. Cosine theta is negative, sine theta is positive. So what quadrant are we in? All students take calculus. So let me go in with an eraser. Cosine, let me highlight. Cosine is negative. So where could that be? Quadrant 2 or 3. Sine, go with a different color highlighter. Sine's positive. Only here. You're at the intersection of those two, so let's try to show it in colors. We're definitely a quadrant 2 angle in there. So that's what we get out of that first information. So now we need all the remaining trig functions. And so this is based upon problem number 38. So it is going to be asked like this in the homework. And so let's go do it. They want us to use the trig functions. We could draw pictures and get the answer, but they want us to be familiar with this. So here's what they want us to know in the end. They want us to know all the trig functions. So I'll put them in order. Sine theta, cosine theta, tangent theta, secant theta, cosecant theta, and cotangent theta. And right now we know 2 of these. When we start out, we know that cosine's negative 1/4, and therefore we know secant's negative 4. So we're there. Now we have to figure out the rest. Well, how do we do that? Well, we can find out that sine squared theta plus cosine squared theta, which we know is negative 1/4 squared, is equal to 1. Or sine squared theta plus 1/16 is equal to 1. Or sine squared theta is equal to, now think about 1 being 16/16. If you subtract 1, we get 15/16. So again, when I put on the square root, it comes with a plus or minus. So let's decide what we need. We're in quadrant 2. Is our sign positive or negative? It's positive. We split up that square root, and we get the square root of 15/4. That's the sign. And so now we know sine, and I'll come in here and put it in blue since we didn't know it originally, is root 15/4. Sorry for not leaving a lot of room there. Now we know cosecant is 4 over root 15, but don't leave it like that. 4 root 15/15 would be a better answer. Both positive because we're in the second quadrant. Awesome. What's left is tangent. So to get tangent, personally, I would say, well, I know what tangent is. Oops, I meant to switch the color. I know what tangent is. If you're okay, I'm going to get rid of this work since you can back the video up. That way it doesn't get so crazy and condensed. But you know what tangent is. You know an identity for it. Currently, there's no Pythagorean identity that would help us because we don't know, well, actually we do know secant. We could use a Pythagorean identity. That would work out just fine. Or we could use that tangent theta is sine theta divided by cosine theta. Or tangent theta is equal to root 15/4 divided by negative 1/4, which is root 15/4 times negative 4, which is negative root 15. And so we get a negative root 15. The negative makes sense, and then cotangent's easy. We just flip that. So that's negative 1 over root 15. But remember, we need to rationalize and say negative root 15/15. Those will be the answers that are in the back. So we have a couple more examples from this section. Maybe we can just do them here. Actually, there's quite a few more. Why don't I break the video from a time perspective, and then we'll segment this 5-1 into 2 parts.